Hello and welcome. I'm Bill Wake. We're here working on a tune similarity program, and we've come a ways. We've got the
Hello and
parse.
welcome.
Whoops.
I'm Bill Wake. We're here working on a tune similarity program, and we've come away.
2 days in a row there. Okay. Anyway, we've come along the way. We've got a Parsons graph which shows the shape of a melody, and we've done the work to parse ABC files to some minimal level that lets us pull out all the notes. Doesn't know the rhythms, doesn't know anything about repeats and all that stuff. So we've got progress. Let's see. So we what I want to focus on today is we have notes and pitches, and they're sort of the same, but they're not the same. Really, I think a note is the pitch plus a bunch of other things, and we haven't really made that separation yet. So I do want to get to that today. First, I think we want to do some finishing work on tunes and errors. So last time we took our result. Let's see if we can find the code. It's even better. Fine tunes. Okay, it takes in a bunch of lines, but it produces a tunes object, which we just created the other day. We did extract class basically, and took an array of tunes and made that into the tunes. Okay, and it's got some accessor type functions. Well, you can get the count. You can make an iterator for it, so you can run sequences over it. But we also have the notion of appending a tune and adding a title to the latest tune and setting the key and adding notes. Okay, so all the stuff that we might do to it, and accessing the contents of a specific tune by index. This latter one, I think we're only using in tests the count and this, but um, it, we'll see. I think that's okay. It's a reasonable thing to make this an array-like object. But what I'd like to do is I'd also like to know what are the errors that were in these tunes that we're creating. Okay, so let's see. Where are we? Okay, attach errors to tunes rather than parser. Okay, yeah. So right now the parser itself contains the errors that happen. Let's see, errors, ABC parse error. I would like to move this field over to the class. Okay, so there are different ways to do it, but one way is we encapsulate the field. So let's find all usages. Okay, some people are asking about it. So there's the creation, there's appending. Okay, so for these errors dot append, let's well, I think we can make a method for that. All right, so I think we will. I'd like to extract out all these pieces. All right, so let's take this line for an example. I'll put the method down here for let's call it add error, or maybe just error, and let's give it the line number of type int, the position of type int, the message of type string. I'm wondering what we can do with this format message thing. Okay. Let's see, this is position from 0. zero based, so position plus 1 makes sense. Now it's 1 based because we talk to humans who think the first column is column 1 for some reason. Okay, now the thing I'd like to do, I think you do have access to this. Let's push this in here too. Okay. And okay. So we have line number. Oh, line is the contents of the actual line. Okay. Well, let's get that too. I guess we can work with substring. I don't know if I'm making a mistake by letting that leak around, but that we can fix. Okay, so now I have this function. Can I use it? Well, I can certainly call it here. Error line number, position, and message. Okay, and that's going to do the append, so we don't need this anymore. This message 2 thing is calculated twice. It's a bit redundant, but we're going to get rid of the other one in a minute anyway. Okay. Format message. Yeah. Okay. All right. So I think that's okay. Let's make sure everybody passes. Now, oh boy, how much do I want to reveal? Okay, so I don't need this anymore. That's a good thing. Now this one, this is a little bit flexible to me. This is the case where we get an exception that shouldn't really happen and is not a parser. So like, what happened? In a way, it's a not expected case, but if I treat error as the message, I still know the line number and the position because that's managed outside in here somewhere. Okay, so let's see. I ran all. Okay, let's push this much. Extract method for messages. Okay, and I'd like to use it here. That one is coming from position 0. I don't even know if it matters that it's 0. I think I can just do it. Error line number, position. It'll add the +1 wherever it is, and error Okay, so that should be the same. Oh, we don't have position. Well, let's do 0 then. That's kind of what we did before, implicitly. Cannot call. Oh, that's make this add error. Error is just an overloaded word there. Okay, use add error for both errors. Okay, so now we had some assertions, right? Parser.errors. Okay, I think we want to turn that into tune.errors. All right, let's make a function get errors. Oh, it wants parser. You know, I think okay. Let's I forget XC test. I don't use it so little. Is at before each? Ugh. I've kind of gotten away from using it. Oh, it's still a good old setup. Okay. Oh boy. Huh. Okay. Very old school. Well, it's override, right? Maybe I can just do this. Var parser equals ABC parser. What if we just do that? The old X unit, J unit would create each instance by itself. So let's see if we can find two parsers. Well, let's see, that'll be enough to prove something. Well, proves I don't know how to type code, doesn't it? Okay, so it seems like it's creating a new parser as it needs it. Should be able to take out this line. Oh, that's a little different. Let's just take parser. Okay. Should be getting to the end. Okay. Okay, so parser. Define parser in test setup. Implicit. Excuse me. Okay. All right. Now, what I'm trying to do is get rid of these. I want to make an accessor for these. I have access to the parser, but all right, let's change this a little. Let's say let tunes equal that. Is that going to help? I don't know. I want to say tunes.errors. Maybe I can. We're talking about 4 places there. I think I'm gonna deal with it here. Okay, so let's take this field. I'm trying to do this in a pretty stepwise way. This is why I'm struggling here. Let's take this and copy it to here. Okay, so the 2 things it knows the tunes, it knows the errors. Okay, and then if you ask it for errors, let's say this is, forget how you do this, private set errors. I think I've done it somewhere. Private parenthesis set var. Okay, so I can let people look at tunes.errors. Okay. And if I write, let's make an add error method. Public add error. And it's going to take an ABC parse error. Okay. Of type ABC parse error. All right. And then all it's going to do is append it. So errors dot append an error. I think I'm going to go to a small talk naming. Okay. And error is a semi-reserved word, so I'm kind of avoiding it. Public func. Okay. And this should all build and run. All right. Yeah, we're doing well. Okay. Now let's write it to 2 places. Where is our result? It's probably local to here, right? Tunes. All right. Let's pass tunes in as well. Okay, that should all be okay. Okay, so we are refactor make tunes available to error method. I don't know, that's a lot to write in a way, but it's kind of the bottom level. All right, so now what I want to do is I want to do tunes.add error, the error. And the error is this. No. Yes. Extract that. The error. Okay. So I'm writing it to two places. And nobody should mind. Okay. Now my asserts, parser.errors. Well, I don't need to look at parser.errors. I can look at tunes.errors. That should cover a bunch of tests. Let's make sure they all pass. Okay. And I can do the others. Parser.errors. This is tunes. Yeah, let's make sure these two pass. Okay. And, you know, I can check this in. I mean, switch from checking parser errors to checking tunes errors. All right. And then we can do the other two. Parser.errors. Well, this should be tunes. Let's call this tunes. Okay. And that should all pass. Okay, and what we should find is nobody's referencing parser.errors anymore. At least to read from. Okay, where are you? Errors? There we are. We'll find the usages. All right, the only place we write to it is in this error method. Don't need that. Okay. All right, and if nobody else is looking at it, there's no point to having it here. Okay. So we've eliminate parser.errors. That's a good thing, I think. Okay, so let's track that. Attach errors to tune. Yes. All right. And then don't write to console. Put them in the report. Okay. UI thing. I don't know what to do. All right. Let's go back to the UI. Report. Content view. Okay. Let's run this. I mean, one thing we can do is, well, let's see. Tunes should be the model for this thing, right? So input and output. Where is the button? Okay, there's tunes. Output is Parsons Code report tunes. Well, let's make some state. Add state array of string equals empty. Okay. And we'll catch it here. Tunes.errors. Those are not they're ABC errors. Is that what we want? Let's see. We could make them be strings. How do we get them stringized now? We don't, right? We just print that out when we find it down here. So we print that stuff. I'm gonna say I think we can make this guy responsible for it, right? So let's take this piece. What are we testing in those tests? Parser tests. Tunes.errors is empty. We had a number of those empty ones. Expected. Okay. Is strings. What's the term for it? And Swift. Swift. There's debug string convertible or something, but there's another one for regular strings. Custom debug string convertible. There's something like it though. What is this called? Basic behaviors. I'm searching for debug because it's the only one I know. Creates a string with a given debug description. Description. Okay, this. Instead, use simple assignments to create a new constant variable equal to this string. I may be misremembering, but I thought there was something that was very similar to custom debug string convertible. Custom string convertible, is that it? Provide their own representation when converting to a string. Okay, yeah, that's what we want. Let's do that. I think that error is up here somewhere, isn't it? Yeah. Okay, let's do extension. ABC parse error is custom string convertible. It should ask us for something. Do you want to do description? Yes. Okay. That's where that code goes. So let's get that up there. Excuse me just a second. All right, so let's just return that. Line number, position plus one message. I think we've adjusted the column already. This is called line, and this is message. Okay. All right, now I want to use that down there. Add error. Okay. Well, I want to say print the error, I think. Well, no, I don't want to do that here at all. I kind of want to take that out of there completely. Message to is only used for the formatting there. Okay, but add error. I guess somewhere in the tests, well, make sure we're green. Right, that one is problematic. And it's like, do I want, well, I think it'll automatically do it. That's the thing I was after. Okay. So I'm getting the errors out. Now, I don't know if I can say if errors dot count not equals 0, then we want a spacer and I think just text for each error. I think we can do list errors text $0. Will that work? No, because I don't know what ABC parser conform to identifiable. That's doable. I don't think that's unreasonable. ABC parser. Make another extension. Oh, I have to do it in the main body. How do I do that? Is it just good? That doesn't seem like it's spelled right to me. Yeah. UUID? There's another way. No, there's definitely an easier way. That was not helpful. I mean, this is doable, but I thought there was just a little tiny call that would do it. Oh, good. Oh, let's see, identifiable. Well, I'll let somebody critique me, but I don't know. Do I need identifiable? Let's make sure. List with text. Okay, that's great. List with some contents. Stuff. ID. You can specify the ID. Well, that might be a way to do it. I don't need this if I'm not going to do it that way. Okay, tests are happy with that. Content is more the problem. Okay, x colon 1, t colon. Let's leave out a t colon key g abc. Okay, should have an error in line. Well, Parsons Code report. This is becoming more of an issue than I thought. All right. Let's see. Somebody's definitely trying to write tunes before they exist. Graph result.graph code. Who calls details? Report on tune. I guess the thing is you get a partial tune, but it's erroneous. Right. So the title doesn't exist. Let's run it again. Okay, x colon 1, t colon title, key G, ABC, XYZ. That should be a problem. Okay. That's right. 5.1 expected note found XYZ. Okay, that's actually a correct error. But I'm going to keep a note that we ran into this other error. I don't think it's urgent, but an empty tune because of header error fails to generate proper report. And maybe that's more easily fixable and I should just deal with it. The problem is tune.titles.first may not exist on the grid. The X will because that's always there. Let's try that again. Okay. Maybe I do want to address it. Let's see. Put errors in report instead of writing to console, though. That we've done, except I've still got it writing to the console. Let's take it out of the console. All right. So down here, we're writing to the console, and same thing here. We don't need to do that anymore because we're going to catch it and put it in. Okay. I kind of like this format error. I kind of like all this stuff to be on the ABC parser. Okay. Let's run again. We're going to do the same one. And actually, I'll do a little shorter one. x1 t title key of G XYZ should get the same failure except in line 4, and it's no longer in our console. Okay, so ugly, but that's okay. I think one thing I can do, I can at least put the text errors found and make that a title too. X1 TT KG XYZ. Yeah. Okay. I'm gonna live with it. It's a bit ugly, but that's okay. All right. So I think we've done that. Now, empty tune fails to generate a proper report. Okay, let's make sure that fails the way I thought it did. X1 key of G should fail. Blow up. Okay. Let's find the Parsons Code tests. Okay. Let's see. Okay, so we need tunes. Oh, wait, what's that coming from? Oh, we got a tune. So we're graphing a tune. Okay, so let's make a tune. Let tune without title equals tune. Reference number is X1. I don't know, 1. No titles. We don't care about the rest. Okay. Reference number 1. I'm not sure that's quite right. Okay. So we got one without it. Oh, interesting. What's the type of this? Notes. Notes type is notes. Can I just create one? Yes. Okay. Let's make one with one note. Okay. Dot natural. Okay, so a C natural is our only note. If we do Parsons, Wasn't it details? Oh, it's report. Well, I'm in the wrong place. That's one thing. Which one got details? And notes. All right, and what should happen? Well, I would say this should just be an empty title, an empty string. Reference number dot space. Okay. And then we're going to look at the grid. Code is a string, so we don't need notes. We just need a code. Somewhat arbitrary. And this is grid equal that. And then, I don't know, we have access to the grid. We got the string form of it. Let's take that. Let's keep this a little simpler. All right. Assert equal grid dot as string. And then I think we're putting one dot space nothing new line star. Maybe a new line. Okay. I reserve the right to take the answer we want. Okay. First, or let's just say junkie. Do I have to put quotes here? Okay. Now I should be able to run my test. Should fail. Okay, 1.junkie is not equal to 1.empty. Okay, so I think if we just default to the empty string. One dot space new line star. That sure looks equivalent. Sometimes you gotta just put it in with a font that you can make sense of, like Courier, so I can put the lines right up to each other. One dot star this one has a space. This one does not. I guess I don't need the space. What's going on here? Okay, so we put the reference number dot space title. Oh, it trims. It trims. Let's take that out in the test. Okay, this should pass. Everything should pass. Okay, so make Parsons Code report work even if no titles are present. Okay, good. And that takes us there. Empty tune fails to generate proper report. Okay. I can just say make empty tune generate proper report. Okay. Generate report. Make, how about this is really tune with no title, generate report with empty title. Okay. Alrighty. Okay, next thing I want to look at is this thing of note versus pitch. And I'm still working my way through the consequences of it, so please bear with me. We started off with note, and note mostly represented the pitch of something as a MIDI number, which the MIDI's like of a digital piano or something like that. They put out a certain number for each key, each position of note on the keyboard. And it's as reasonable as any other encoding, I guess, for us. Let's see, where's note? Okay, here's pitch. All right. Now, the other thing we do is we allow we got multiple things buried in here together. Okay, we've got the note value, which I probably should call pitch, really. Pitch is a MIDI note number. That seems plausible. Okay, and we also have the name of it. So if you say F sharp, it's in a particular octave, octave 4. Well, if you say C, natural 4, you're talking about middle C on the piano. So if you ever had a piano lesson, they probably started you off playing songs that start on middle C. And C natural 4, it corresponds to that. Now that's more information than just the pitch at the MIDI note level. And the reason it's a little funny is you often have multiple names for any given key on a piano. I mean, you think of F sharp as being, one of the black keys on the piano is F sharp 4, the one above middle C, right above middle C. But you can also call that G flat, okay? Because the notes that are sharps, you can look at them as either sharp, raising a note, or a flat, lowering the note above it, okay? I don't know if I can, you may hate me for this. Okay, so here's C. Let's do it this way. C, and then I should put this in comments. Okay, I'm going to draw a little piano keyboard here. C sharp, D, E, let's see, C sharp, D, D sharp, sharp, E. Then there's no E sharp per se. F, G, A, B, C. Okay, and then F sharp, G sharp, A sharp, and that's it. Okay. And if you ever looked at a piano, you'll see this thing of 3 white keys with 2 black keys, and then another group of 4 white keys and 3 black keys. And you see a group of 2, group of 3, group of 2, group of 3 for those black keys all the way up. But I call it F sharp, but it's really also G flat. I could go down this way. Now there's also the notion of double sharps and double flats. So F double sharp is F sharp is the same pitch as G, even though it's written F double sharp. Okay, so the note and the pitch are clearly a different thing, because F sharp, G flat, they're 2 different names for the same pitch. Okay. In some contexts, they're the same. You're just comparing pitches, like our Parsons Code melody things. Is it going up or down in pitch? Okay, we don't really care what name you call it. Other things care about it. So if I'm doing an analysis of the key changes in a symphony or something, the fact that we chose to call this a F sharp versus a G flat is meaningful and important and significant. Okay. And the fact is, there are instruments other than pianos, and some of those instruments, like violins, can play F sharp and G flat a little differently. And the reasons for it are complicated, but pianos kind of make a compromise. Well, there's different ways of tuning, and pianos make a compromise that we call equal temperament, that says, well, if you got the sharp between 2 regular notes, let's kind of space them proportionally equal. Okay. And it's actually the 12th root of 2, because it's 12 numbers and you double in pitch or frequency from C to C. Okay. And that's kind of a compromise, because there's another thing called the overtone series that's basically, Pythagoras discovered this, like the Pythagorean theorem guy, and whatever, several hundred years BCE, 600 BCE, 5 something BCE. One of the things they discovered was these overtones, that if you do C to G, that's got a particular relationship. Okay. And if you do G up 5 to D, that's got a particular thing, and D up 5 to A and all that, they all have these very resonant, kind of distances involved. But if you keep doing that, all of a sudden you get around and you realize that the C you got to starting on one note and the C you get to on another note don't have exactly the same pitch. And that kind of corresponds, if I were playing in a sharp key or a flat key, a violin might make slightly different F sharps or G flats, make a distinction there. We're not trying to do that here. As far as I know, ABC notation doesn't deal with that. Okay, so we're going to not worry about it too much. But there's another layer on top that one is this notion of the accidentals. Okay, well, first we have the pitch, then we have the accidentals. Then there's another notion of the key, and the key of a piece of music is sort of like a predefined set of sharps or flats. So the key of D just has F sharp and C sharp instead of F and C. And so if you play a scale in the key of D, you go D, E, F sharp, G, A, B, C sharp, D. Okay. And so if you write a C in the key of D, it's implicitly a C sharp, unless somebody comes in and explicitly makes it accidental that says, no, it's not really a C sharp. Okay. So we have this third layer on there. Okay. Now, we sometimes definitely just need the pitch, and we just want to compare them for higher or lower. Other times we want to get into the rest of this stuff. And then there's other stuff that we parsed, but we ignored. Let's see if I can... we have note parser somewhere. Let's go to note parser. Okay. Note parsers. So the note, it can look for accidentals and upper or lower letters. That's all fine. It can have an octave modifier that tells us what octave it's in. Middle C, an octave higher than that, and so on, or lower. And then a duration, like, is it a half note or a quarter note or a one and a quarter note or whatever, It has a lot of variety there. Okay. And all that stuff could be the note. I don't quite know where to draw the line. And then there are further things that can go on. There's grace notes and there's touches. You can either, like on a fiddle, you can pluck the string or you can just bow it. I play mountain dulcimer. We can strum it. You can make a harmonic where you don't hit the whole tone. You're just kind of, I don't know. It gives a bell-like tone to it. Very pretty, but is that the note or is that not the note? So I don't know what the note really is. I mean, I can think of 18 variations that it could be, but which one makes the most sense for us? I'm struggling. Okay, but I do think we we definitely have a distinction between the pitch and whatever else this note is, and I want to bring that out. Okay, where's note? Pitch. Now, I used to call this note, and now I call it pitch. I want to split back out and make notes contain pitches, but I also want to make sure that when you ask for the notes here, like this sequence is what the Parsons Code needs. It needs the sequence of pitches. It doesn't need rhythms, doesn't need any of this other stuff. It just wants to know the pitches. And so I think I should be asking for pitches here instead of notes. And then the tune itself, I think that's a derivative. The tune should know the notes, and then we should be able to filter down and say, just give me the pitches. Okay. So I think this thing of given a sequence of notes, you can get the pitches from it is actually the kind of thing we're after. And I don't know. We'll have to see what that entails. All right. I've been touching files. I don't think I've made drastic changes, but let's get them in. All right. And the differences, deleted a couple lines, renamed the interior name, and I referenced that name once in a test. Okay. Rename pitch dot note value to pitch dot pitch. Okay. All right. So the change I want to make is I still want pitch to be a sequence of pitches, but I want notes to be something else, and I want to make tunes hold notes, and I don't know what they hold now. Let's go find tune. I think he probably holds pitches. Oh, a tune holds the notes. Okay. So I think there's another object, pitches, that knows how to get notes, pitches from notes. Okay, and maybe it's a small object. This maybe, yeah, we're gonna split it up. We gotta figure out a way. Anyway, we're due for a break, so let's take a 3-minute break. We'll come back and we will. I think we'll probably introduce pitches as a separate concept, and I don't know. Maybe there's a way to make a filter. Pitches be a filter of some sort. Because really, like pitches, notes has to know the notes, and pitch is going to be like, for each note, give me the actual pitch kind of thing. So maybe the place to start is splitting up notes, and we'll see what we can do. All right, 3 minutes. Thanks. All right, welcome back. Let's start with pitch. All right, so what I want to do is extract out the pitch and say that a note knows its pitch. Okay, and I'm going to rename pitch to note, I think. All right, let's take this out. Okay. If I name pitch, all right, let's name this to note again. It used to be called note. Here we are again. Note. Okay. Now, the pitch, I want to do an extract class on that. And then eventually we probably want to push this onto pitch. Okay. Let's extract class. So we'll make a class pitch. Okay. And we're going to let this have this. And who references pitch? Well, it gets set here. And used for comparison. Okay. So we'll need to be equatable. And then used for lower than and same pitch. Okay. Has no initializers. Okay. So we do this. Node index equals nil octave. I think wow, that's well, it's setting it there. Let's just add it. Okay. It's taking a MIDI note number, I guess. Init of MIDI pitch. Well, let's just say pitch number, and then self.pitch equals pitch. Okay. And then let's see, what does anybody else do? Well, they reference the pitch. I guess we've provided that. And I think we could say is lower than. Well, let's take all these. Okay. Is lower than pitch self and other of pitch. Okay. All right. So a pitch can compare pitches. And then the references, we create it here. Note index plus adjustment. Okay, the adjustments, yeah. All right. And we don't reference it otherwise. Okay, this should be harmless. And actually, we have a rename and a rename pitch to note. Extract class pitch. All right, we haven't used it yet, so there's no problem there. Okay, and then we need to use it. Okay, now this here, I think. Well, it seems like gosh, I don't know. It's like I want to make pitch able to do some helping with this, but it's kind of complicated. All right, let's just start with pitch equals pitch of this. Okay. And pitch now has to be type pitch. All right, and any reference to pitch has to, well, we have to add equatable now. And it should tell us what it needs. Help it along there. Okay. And then we're going to return LHS.pitch equals RHS.pitch because all we have is pitch. Kind of makes it simple. Okay, so that one's good. That's fine. And let's self.pitch less than note.pitch. Self.pitch is lower than note.pitch. And self.pitch is same pitch as note.pitch. And I'm going to call this other. All right, and this should just work. Ka-dunk. Conflicting arguments. Whoops. What happened there? Yeah, conflicting arguments, generic parameter T versus MIDI note. What does that mean? T pitch versus MIDI note number. What's expected? Oh. Let's make a pitch out of it. Notes pitch should be a pitch. Yeah, that seems reasonable. Okay, so we've made extracted class pitch work. Note delegates to it appropriately. Okay. Now, I want to go through and question these people. Well, okay, let's see. First, let's clean up a little bit. Okay, I got notes.swift. I think I want to make a pitch.swift. Let's do that. Okay. I believe this belongs over there. And this. Pitch belongs over there. Okay. Now, that should just work. How do you have two syntax errors and you're compiling? Let's clean the build. And let's make sure note got put where it should. 10 sim down. Yep. Okay. move pitch to its own file. And that's really a refactor. Now all this adjusting gobbledygook. I would love to make pitch understand the octave stuff. It seems reasonable enough to me to say you're X half steps above. That feels okay. If you're not in the list, right? I guess that's this thing. If note name is not in the list, that seems more like an error in the caller. Okay. So if I gave pitch a constructor that said, tell me the octave, maybe you have to say octave plus 1, and the note index half steps above C, and the adjustment. That seems like a good thing for pitch to know. Okay. Init, that was the note index. Well, let's say the octave, the half steps above C, and the adjustment. Octave, and this is one where I might use these names. Octave is an int. Half steps above C is an int. And the adjustment is an int. Okay. And we're going to store, well, I would say octave. Why is that plus 1? Let's take this. Okay. And then say pitch equals octave plus 1 plus 12 plus note index. Well, that's the half steps above C. Okay, I'm going to have to, I think this plus 1 thing is, I bet you well, I don't know. I don't know if I'm thinking maybe the default octave in ABC notation is an octave below the one in MIDI, or octave above, or a something. Okay, let's see if we can work that out. ABC notation. Let's find the octave modifiers. pitch. Let's try pitch. Okay, so using the treble clef. Okay, so that's, wait a minute, C. Okay, middle C is there. Why would that? Okay, C there, and then let's find the MIDI note for middle C. I think that's octave 4. MIDI note number 60. Okay. Whoa. Sorry, there's 2 standards? I didn't know that. 60 is middle C, C4. And I think that's what we're saying here. C4. Oh, right, but in MIDI, that's 60. So it's not 4 times 12, it's 5 times 12. Okay, so it really is the MIDI side that wants to treat this. This is the music side, the traditional numbering or a traditional numbering of octaves. This +1 thing is the MIDI side. Okay, and this is, let's say let MIDI octave equal octave +1. Okay, I think that's going to help. MIDI octave. Okay, so if you do it this way, you pass in the octave 4, I turn it into 5, 60 plus the half steps above C. C has 0, C natural has 0. That would be 60. If you said 1 half step above C, like, well, in our case, we won't do any of that. We'll just say, let's say D. Let's say D sharp. Okay. D sharp 4 turns into 60 plus 2 plus 1 for the sharp. So 63 is D sharp / E flat. Okay. That sounds righter. Okay, and so I should be able to use this initializer in note. Oh, but we have this. If note index equals nil, it's not even a valid note. Okay, let's break it up. If pitch note index is nil, okay, we'll pull the conditional outside. Pitch equals, if the note index is nil, then something pitch sub 0. Otherwise, pitch of octave node index and adjustment. Okay, that's, yep, put those in for me. Thank you. All right, that's note index, bang. That should be neutral. All right, and then this unknown, I'm going to make an unknown. Well, I don't even know if I need to set it. I can say private static var unknown equals pitch sub 0 minus 1 0. Octave. Okay, let's see if nobody's using it, so it shouldn't be a problem. Okay. Half step node index. I still think this half steps above C is a better name for it. Let's call it half steps up at least. Octave. Okay. Alrighty. MIDI number is 0 for non-note letters. Check number. I don't know if that should be in key. Okay, I think what's going on. Okay, tunesim.pitch. All right, let's give this thing a custom string convertible too. Custom debug string convertible. I think we're using it for just debugging at this point. Let's just put the number. Okay. All right, let's run those tests again. I think something's up with the octaves in this case. $11 is not equal to 0. Okay, let's see the test. If you say create, I think you're saying create the MIDI note with H octave 4. I expect a MIDI note number of 0. MIDI note number, note string octave and create a note with the note name, accidentally octave, and look at its pitch. So you say H, natural, and octave 4, right? Or H natural 7. How many numbers coming up? 11? That something's funny. I don't know if 11 is minus 1 times 12 plus 4. I don't know. That can't be right. Check mini note number. 11 is not equal to 0. 11 not equal to 0. Pitch. Oh, maybe I've. Yeah, pitch. Pitch of expected. Okay. H accidental octaves pitch. Let's go find that thing. All right. Let's just run the test with some breakpoints. Okay. Okay, no name H. Accidental is in key. Octave 4. And okay, so we'll go over. Okay, front half steps up. Should be a nil, right? Nil. Okay. Pitches, if it's equal to nil, true, then it should be pitched and unknown. Step over and pitch. Pitch is 11. Whoops. Is my number wrong? Pitch should be -2. We're trying to force this thing down to 0. We'll just continue. Sorry. Let's run tests. No. Dan. Okay, have I got things wrong? Ugh. Half steps above C. Yes, I do. 0. I don't want to add any half steps. Octave. I think octave should be -1. Okay. Try again. Okay. Add constructor for pitch. Now I'd really like to take out this other one. I think some tests are using it. Right. Do I need to check MIDI note number on a note? Well, that sounds more like a pitch test to me. Well, except note. Okay, let's name this check pitch. Okay, and this is I'm going to say it's pitch C, no. Octave 4, 0 half steps up. Zero adjustment. Okay. Check pitch should take a pitch. Okay, we got a few to change, but I think that's going to be better. Need labels. Let's make a helper. Okay, this can be. For E is 5, no adjustment. 7, 0. 4, 9, 0. Okay, that should be okay. Pitch, returns pitch. We got implicit return. All right. That should be okay. Now H should just be pitch dot unknown. Pitch dot unknown. Okay. This should be pitch octave 4, 0, 0. Pitch 401. Zero minus one. Double flat minus two. Okay, and who else is complaining? Okay, make tests use pitch, not MIDI note number. Okay, and I guess I left that commented. All right, and then this is internal. Can I do this? Okay, is anybody grabbing pitch? Private. I don't think so. Okay, now whether we need to. Okay. Okay, I think that's progress. Let's see. Now, this stuff, I don't know, sometimes I format this like this. You tell me. I think it'll probably get reformatted at some point. Octave. Wonder what anybody does with octave. We definitely need it for some things. Don't know. Okay. Now, where's my notes? Note. Close this for a little bit. Okay, here's notes. Let's see who's using this. Okay, I think this is I think it's more or less accurate that notes or a sequence of notes or a sequence of note. In effect, an array of note, but we treat it as a sequence. And you can iterate through them. Now this is all right, and it's used by the parser. That's a good thing, I think. What is not so good, it's used by Parsons Code. Notes is notes. I think this should be pitches. And I think whoever calls analyze should be responsible for doing that. Which is really this. Oops, this. Encoder equals analyze notes. Tune.tune. Okay, let's go there. Is the notes. Okay. I'm going to say we're going to call that notes. I hope that doesn't create. Okay, that one's fine, but this one's the tricky one. Ooh, refactoring bug. Okay. This should have been self.notes. Can I undo that? Okay. Let's make sure everybody's specific. That's fine. That's fine. That should be self. Well, I don't know. It has to be that. This could be new notes. More notes. Okay. I don't know. We have set tune and add notes. Okay, but I think who references notes tune? It's a bunch of tests, right? No, just this. Okay, so let's change this to notes. And then this is debug string, so I think we can do that. Okay. All right. Now, back. Can I can't go back. Can I do that? No. All right. Let's find set tune and add notes. Not used. Okay. good. All right. What's that tune, wasn't it? Okay. So given a tune, we can add titles, set the key, add notes. All right. So let's go back to our Parsons Code situation. So on tune notes. Okay, so the parser using notes, that's fine, But Parsons Code, I want it to take pitches. And pitches doesn't exist. Notes is a sequence, and we're using it that way here. Maybe that's not the business of this. Can I get from a note to its pitch? All right. Well, I think I want to say, oh, it's a let, so it's only read, not written. And pitch provides no modifier functions, just testing functions. Okay. So I think I can say note.pitch. Okay, so Parsons Code, let's take let pitches equals notes.map $0.pitch. So convert each note to its pitch. And if we zip pitches together, does it work? We'll fix the names in a minute, but it should work. Yeah. Okay. So now this is pitch 1. This is pitch 2. Whoops. Pitch 2, and that should just work. Okay. Now, give me the notes. I turn them to pitches and just return them. That's probably good. Could the caller do it? That's the question. Who are the callers? One place, really. These. notes for that. That's giving me a string of notes. Well, that seems like a good thing for the parser to do. I just don't know if I want to do like map $0.pitch here. Let's do that. Let's make this pitches. Well, do I need to? Pitches. There is no pitches. Wait a minute. Maybe this is okay. You're sort of saying, give me the tune, and then I'll strip out the stuff. That is not at all unreasonable to me, because I'm going to have another code that quantizes. Okay, what if I did this? Whoa. Say all of a sudden it likes it? No. I don't know. I want to say sequence here. I really want to say sequence of something, but I don't think that's the Swift way. I think this is really the way. It should be able to make it generic. T is not used in the function signature. Can I say sequence of T? Cannot specialize. And that could be confusing. T is not used in function signature. Pitches in scope. Okay, let's put this back to notes for a minute. Let's say, is that okay now? T is not used in signature. It must be in any sequence. Generic function T not used, and then zip some sequence. Value of type S is no member lower than. Okay, so no, I think Maybe this is good enough for now. Okay, let's see what we're saying. Note versus pitch. So this is really extract class pitch from note, and then make Parsons Code analyze pitches rather than notes. Okay, that's the two things we did. Now, the thing I'm wondering about is, does note need to know that is pitch less than? That seems extraneous to me. Never called. Okay, so we've converted to pitches. Okay, this test, note test. Okay, same pitch as, well, let's make this FN key is not the same as F accidental. Okay, so this is, well, it's kind of the key of G. If we're saying F becomes F accidental. This is an interesting question. Are two notes the same if they're written differently? I guess is what this is doing. So F in the key with an F sharp is F sharp. Is that the same as just an F sharp not in the key? It's the same pitch, but it's not the same note. So F in key dot pitch should equal accidental dot pitch. I believe that. What was this before? Is same pitch in F assert equal F in key dot pitch is the same as F accidental dot pitch. They have the same pitch, but one was written as an F in a key. I guess that is probably what I believe. We'll have to see more about what note comparisons are done. Okay, there's check key accidentals being called. So if you're a note in the key that happens to be F sharp, you're not the same note as an F sharp, a plain F sharp, even though you have the same pitch. Okay, I believe that's what we are saying. I don't know if it's a good long-term concern, but that's okay. Compare pitches of notes in key versus not. Okay. Now, is same pitch as. I don't think it's got any users. Right. Okay, so take this out. It's not a common question. The only place was one test, so it's not critical to our reporting at all or any features we have now, so that's fine. Delete is same pitch and is lower pitch from note. Now unused. All right. And our to-do, well, that's, I guess I would say remove pitch comparison from note unused. Okay. Turn tunes into a sequence of signs. This is probably not relevant to our current features. Like, we turn everything into notes, and then the report turns them into pitches, and that's cool. There are, well, even in no scaling, we can see it. Like, here's a pitch, but here's a bar line. All we do today is ignore that. It's not treated as anything. Let's find a more interesting case. Here's a repeat sign, which says, go back and repeat this whole first two lines. And we call it A part, B part in this case. You got the A part repeats, so it's AA, B, B, because this also repeats. If you don't put the initial repeat, it sort of it picks it up by default. Okay. It's a little weird to have the half measure here. Another day. Okay. All right. So this already, there's something going on with bar lines and repeat symbols. And then there are other things that can happen in here. Mostly this file doesn't do it. We do have this little grace note. I'm going to say, yeah, there's not too much. So far we just have repeat signs, bar lines, and grace notes. And the grace notes right now, I think we treat as a separate thing. I don't know. They maybe should be part of the note or something. When you perform it, it's considered, you play it quickly, a trill, say, but it's part of the rhythm of the note. It's there. And if you analyze the melody, normally analyzing the melody or the harmony, you wouldn't worry about the grace notes too much. The singer might leave them in, put them in, take them out, might not play them the first time and then play them the second time. That's pretty common. They're there to let you build interest, make your brain not go, didn't you play this once? I'm bored. Okay. Alrighty. Any other little weird symbols? Well, there's a double bar line. Okay. Another bar line formatting thing. We don't handle rhythms yet, but you can see these bar lines do matter because they control the repetition of the piece. Now that's a little odd. There's no ending bar line. You should have probably a colon on this one. I don't know. Have to get her to take a look. All right. So I think the bottom line, this is going to be needed in the future, but it's not really critical for us now. All right. Change the report to show the reference and title on the first line, Parsons Code on the second line, and following lines, and split everything through 32 characters, followed by the graph. Okay. We can start that. That's a bit of a new feature. So I showed the report to Fiona, who provided the no scaling file to me, And it's like, well, I want the whole graph, not just the first 8 characters, which I hadn't gotten around to anyway. Like, oh, the whole graph is interesting, but having the title on the far side of the whole graph looks weird. So we're going to put it on the middle there. Okay. Let's see, where is that? Well, it should be organized in here. We got domain, parser, Parsons Code report. Okay, so yeah, this is interesting. Okay, yeah, so our report is take all the tunes, sort them by their Parsons code, and then for each tune, put its report in. Okay, the report is find the code, build the graph, build the title, and then we used to say, hey, line up these things with 4 spaces between them, but I think we actually want a vertical. I don't know if we have a plus vertical. Okay. Yeah, we don't. Okay, that seems doable. If we do the grid. Okay, so let's keep grid around. And I think we can drop pitch and notes and note test. Parsons Code tests. Okay, yeah. So Parsons Code, that one's fine. I think the Parsons Code report test. Yeah. So we would like to have the one just see blah 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 over here, and let's do that. Just see RRR. That makes this go to nothing. That, and I would say a blank line. Okay. Twinkle. And this is where, I mean, it's 3 tests so far. It's not horrendous, but it's a thing. It's a decision that is affecting multiple tests. So it might have been better to I don't know, find a way. Maybe if our tests had been more independent of this formatting, I don't know. I mean, the test really was checking as much as anything that the side grid stuff worked. Okay. So who knows? Okay, so that's what I'm saying they should be now. And okay, throws no area, no title exists. Okay, these tests should fail because the report's in the wrong place. Okay, where's the checker method? Here we go. Okay. Oh, runs them in an interesting order. Okay. Dash down some. That makes me think I've done something wrong here. No? Okay. This down some. Oh, that puts it side by side, but now I've moved it. Okay. I think that's legit. Interesting. Okay. I don't know what that means from a graphical point of view on our grid. I mean, when you append stuff horizontally, you're keeping the same axis of the two things so they line up in a certain way. You could imagine wanting to center them or do other things instead, but the way we defined it, each one has a zero, which may be high or low, but the zeros align. The new way, I want to take an existing grid with its own zero and another grid with its own zero and slap them together there. Well, where should the zero be on the new grid? I don't know. Maybe the bottom? We probably need to define that. I mean, we do need to define it. That's what a grid means, is something with an axis on it. But it may have been premature. I don't know. So, or maybe we keep the original grid. That would work too. Okay. We'll have to decide that. So that'll give us something to think about tonight. In effect, we need a plus vertical to put the report title and then the details. The graph. Sorry, the title, then the graph. Title, Parsons Code, space, and a graph is what we want to see. And we'll have to define how that works. I think it won't matter too much which way we go. A future use might care more. So anyway, let's see. Tomorrow we'll be meeting Eastern Time, 1 to 3:30 p.m. or UTC at 6 to 8:30 p.m. I normally do this Monday through Thursday, but this week I'm cutting it short. I'm heading out for a change. So tomorrow is the last day I'll work this week on the video. But next week I'll be off, and then a day or two the following week. We'll see how that goes. Depends on the travel. But with a week off. So hopefully tomorrow I'm very sure we can get this grid stuff worked out, and that'll fix the report. And then we'll see what we want to do from there. I think it's almost time. I think this thing should wait. I'm going to put that out of the no scaling report. All right. So if we finish this tomorrow, I can give the app to our sole real user and say, okay, here's the way this looks, and you've got something. ABC parser getting too large. That's my opinion. I don't have anything concrete I want to do about it at the moment. It's just that as we add more and more parsing, it's getting larger and larger, and time to break out some sub parsers. This was a problem in the real data. We could treat it as part of the fix, but we'll see where we get tomorrow. All right. Thanks for joining, and hope you have a good evening. Take care. Bye-bye.